Solve this question based on Newton's law of universal gravitation. Now, the question says we should find the gravitational force of attraction between the moon and the earth if the mass of the moon is 1 over 81 times the mass of the earth. Now, they gave us some parameter. They gave us that G equals 6.67 times 10 raised to power minus 11 Newton meter square per kilogram square. They gave us the radius of the moon's orbit is 3.58 times 10 raised to power 5 kilometer, and mass of the earth is equal to 6 times 10 raised to power 24 kilogram. Now remember what they ask us to find. We should find the gravitational force. Now that means all the parameters are given. So we're saying that F equals gm1m2 all over r square. That's the formula. Whenever you hear about gravitational force, this is the formula you use. F equals gm1m2 over r square, where m1 is the mass of the first object, m2 mass of the second object, g is the universal gravitation, Newton's law of universal gravitation, like the constant. Are you getting it? Which is what? 6.67 times 10 raised to power minus 11 Newton meter square per kilogram square. You ought to know that, right? And r is the what? Distance apart, distance between them. You get the point now. So we're saying that gm1 m2 over r square. Now here our m1 is the mass of the moon. Now they didn't give us actually the mass of the moon, but they gave us a clue to get the mass of the moon. Now we said the mass of the moon is equal to 1 over 81 times mass of the earth. Did they give us the mass of the earth? Yes, and that is m2, which is mass of the earth is equal to 6 times 10 raised to power 24 kilogram. So, and our g is equal to 6.67 as I've already said, and our r, which is the distance apart, is equal to 3.58 times 10 raised to power 5 kilometer. Now back to the question. Remember that we have our g. Now our m1 is a clue but not actually a value, so we want to find that m1. Now to solve for that m1, I hope you are seeing what is on the board. That's why I had to focus it on my board after solving so that I can explain it better. So now our m1 is equal to the mass of the moon. Now m1 is mass of the moon, which is equal to 1 over 81 times 6 times 10 raised to power 24. Now where do we get 6 times 10 raised to power 24? We got it from the mass of the earth. So mass of the earth is equal to 6 times 10 raised to power 24. And now to get the mass of the moon, we'll do 1 over 81 times mass of the earth. Now after so much solving, we got that mass of the moon, which is our m1, is equal to 7.45 times 10 raised to power what? 22 kilogram. Now our m2 is already there, which is mass of the earth, which is what? 6 times 10 raised to power 24 kilogram. Now our r have already been given. They gave us what? 3.58 times 10 raised to power 5 kilometer. Now there is a discrepancy there, kilometer, not meter. Now I want you to understand that whenever we are talking about distance, distance is always in what? In meters, not in kilometer. So what are we going to do? We are going to expand that kilo. So we have that 3.58 times 10 raised to power 5 times 10 raised to power 3 meter. Because whenever you hear about kilo, kilo is talking about 1000, and 1000 is 10 raised to power what? 3. So we say that our r will now be 3.58 times 10, 3.58 times 10 raised to power what? 8 meter. You get? So 10 raised to power 5 plus 10 raised to power 3, which is what? 10 raised to power 8. That's by the way. So focusing on the force, we say that F equal to 6.67 times 10 raised to power what? Minus 11. And our m1 is equal to what? 7.45 times 10 raised to power what? 22. And our m2 equals what? 6 times 10 raised to power 24. And then our r is equal to 3.58 times 10 raised to power 8. Now all squared. I hope you can see what we are doing here. Explain the first F. Now the second F, now you say that we want to take the values because they are attached to the standard forms. So we want to take the values, ordinary values. So what are we going to do? We're going to say 6.67 times 7.45 times 6. So these are the values, and then we shift the powers separate. So we do that, and then if you shift, if you look at the right hand side, you see 10 raised to power minus 11 plus 22 plus 24 all over 3.58 all squared times 10 raised to power 8 all squared. So after all calculation, for the numerator, we got that 298.149 times 10 raised to power 35. That means after doing the standard form, we got what? 35 all over 12.8164 times 10 raised to power 16. Now we have that F is equal to 298.149 over 12.8164 times. Now this denominator, that 10 raised to power 16, 16 will go up. You understand? It will turn to what? Negative. That's the rule. You understand? Maybe I will organize a class on standard form so that you understand more about that. So we have that F equals now 23.26 times 10 raised to power 19, because 35 minus 16 there will give us what? 19. So we have F, which is our force, equals 23.26 times 10 raised to power 19 Newton. Or if we want to shorten it and increase the standard form, we can say F equal to 2.326 times 10 raised to power 20.